Let me see if I can get the lights adjusted a little better from last time, because last time they were pretty dark. Let's see how that works. That's not bad. And how about this? Let's just go with that, because last time it was pretty dark. All right. So let's get started. A few quick announcements as we make it through our second week in our freshman engineering seminar. First off, we're starting to enter sort of a regular mode of operation for the class. So what I mean by that is each week you'll be assigned a quiz online. So the quiz for this coming week, I'll probably have that completed sometime this afternoon once I've collected all the attendance and made up the questions and whatnot. And that'll be made available all through next week. It will close next Friday at 11 a.m. So I looked online right before class started. It looks like just about everybody had completed the quiz from last week, and everybody pretty much did all right on that. I also wanted to mention Marshall University's Career Exploration Experience. It's basically an opportunity for you as freshmen, and it's also open to sophomores, for you to do job shadowing. Now, there are 4 opportunities this semester. 2 of them are in October, on October 10th and October 17th, and 2 are in November, on November 2nd and November 9th. I've got some requirements here, and by the way, I also have a PDF of this slide uploaded to Blackboard, so if you don't get the URL and whatnot written down, that's no big deal. If you're wanting to do this, if you're wanting to job shadow on the October dates, you need to have your application in by September 26th, and if you want to do the November slots, you need to have your application in by October 19th. And there's a series of requirements. You'll need to have a resume and be able to attend a workshop and be available on the dates that you select and apply for it and what have you. So if you're interested in that, the link is right here. Again, I also have a PDF of this available online. Any questions? All right. So like I said, we're going to sort of enter a standard mode for the next few weeks. So the way that the seminar will run is the first thing that we'll have is a short faculty introduction started off, and then we'll have our main speaker. So I'm going to start off with our faculty introduction. So the faculty that's going to be introducing themselves this week is Dr. Asad Salem. Dr. Salem is the chair of the engineering division, so a lot of you will probably see him if you've got any sort of paperwork requirements or anything with that. But he's also a professor in mechanical engineering, so I'm sure some of you will get to know him pretty well. So let's start off. Let's give a round of applause to Dr. Salem. I'll get your PowerPoint set up.
Good afternoon. As Greg mentioned, that my name is Dr. Asad Salem. I'm the chair of engineering, and my office is at the Weisberg Applied Engineering Building, which is, this is the map, this is second floor, and our office is here. This is the stairs over here, and if you come up the stairs to turn left, and you see a sign engineering sticking out from here, and this is our office where you have any questions and so. Okay, I came to Marshall. This is my 6th year. I just started this month, my 6th year. Before I came from to Marshall, I was at RIT, Rochester Institute of Technology, and this is to give you some background about my education. I finished my bachelor's in '83. Mechanical engineering, and my master's in '89 and my PhD in '96 from Akron. Between these years, I was working in different fields. This is only to show you my last industrial experience. I became an engineering manager from '91 to '97 at Spectrum Plastics in Akron, Ohio. Custom injection molding. We design products, highly engineered products, and we build the molds, and we manufacture them. After that, after I finished my PhD, I went to Dover Industries, I was Director of Research and Development in plasma and metal cutting. All the time I had my love for academia. I mentioned that after I finished my PhD in '96, I went and worked overseas in academia as assistant professor at a university in Jordan. I came back to academia in United States in the year 2000. A few years later, I went to Texas A&M. I established a mechanical engineering program at Corpus Christi. And then I moved to Rochester Institute of Technology to manage their branch in Dubai, establishing engineering, different disciplines, undergraduate and graduate. And I was fortunate to come over here in 2013 to become the chair of engineering. Since I came over here, we studied mechanical engineering, electrical and computer engineering, and biomedical engineering. Therefore, let me see hands. How many of you are mechanical engineering? And how many of you electrical and computer? And biomedical engineering? You are not supposed to be here in this class. I remember now. And what about civil engineering? Okay. This is my experience in academia and what I do research. My original background is thermofluids, fluid mechanics, heat transfer, thermodynamics. These courses you'll become familiar with when you start moving into your engineering program. Computational fluid dynamics, which is basically using computers to model the flow and try to see, understand how things happen instead of going to experimentation. Then you gradually move into areas that it's within your background, but they do development in the field, you find yourself into these areas. Therefore, I'm involved also in renewable and alternative energies. I do mainly wind energy and I work in LNG, liquefied natural gas. You are familiar, most of you, with getting natural gas from the ground in some areas where we have a huge amount of it and areas we don't have any of it. Therefore, people need to use it. Sometimes it's not easy to ship it. Therefore, the best way to ship it is for that application is to cool it down to a point that it becomes liquid. And then ship it in special tankers to countries where they need it. During this process, there are a lot of emissions, pollutant to the air, methane, as well as CO2, carbon dioxide, and other heavy materials like propane and other butane and other gases. Therefore, we need to make sure that we are not polluting the environment. We are emitting the least amount possible. And also, once you cool it down, to ship it, in large ships takes about 3 weeks to 4 weeks in the ocean, moving different climate zones where you need to keep the pressure inside the tanks, otherwise they explode. Therefore, you need to evaporate it under control, and you need to find ways to use it and utilize it for something beneficial, not just emitted to the environment. And that's one of my research interests. Wind energy is important. Recently, I'm involved in a project. Maybe I'll recruit some of you to work with me in helping poor countries in Chad and Mali and Niger, where they have medical facilities and they don't have electricity. Therefore, we try to generate electricity from wind turbines, wind energy, or using solar energy for different applications. Energy conservation and sustainability is very important. We have to conserve what we have. We have to utilize it well, and also make sure that our resources are sustainable. Because if they are not sustainable, that means we're going to run out of them. And that means to bring a new source of generation or source of energy is going to be very expensive. And sustainability is much bigger than mechanical engineering. I only interested in a very small sector. Sustainability in civil engineering and chemical engineering and electrical engineering is a huge field, and probably this is one of the areas that has a great future. Therefore, if you think about an area that's going to see a lot of development and progress and expansion, this is one of the areas probably you should think about when you try to specialize in one of the areas. Whether you are civil engineering, environmental, mechanical, electrical, computer, sustainability is very important. Now, my office hours, I don't have office hours. The whole day is office hours for me. You want to see me for any issue, this is my email. And what you could do, you could go to our website, click on my email me, and ask me that you want to meet with me. Or take your chances, come to my office, and if I have open door policy, please stop by. Sometimes you have to wait. But if you send me an email, we'll make sure that you fit in my calendar, and then you don't have to waste your time. Do you have any questions?
Any questions for Dr. Salem?
One thing for people with mechanical engineering, I want to tell you that we finally got the ABIT accreditation for the program last week. The program started, we got it after we started in 2015. Therefore, we got it almost 3 years after we have started. And this is the plan for electrical and computer engineering. Hopefully, we'll go for ABIT accreditation after the first group of students graduates in May 2019. And they will visit us in October next year. And we'll get the final results hopefully August 2020. Takes a year to tell us. They give us indications once they visit us that where we stand, but officially they inform us almost a year after that. We'll keep you updated in ABIT accreditation. It's very important. But I could say that from the our faculty are very dedicated to this purpose. They are working hard and they are very experienced on this. Therefore, you don't have to worry about it. Any questions?
First off, let's give Dr. Salem a round of applause.
Thank you.
Before I introduce our main speaker, I thought of something that I should mention real quick. So I saw a bunch of you scanning the card scanner coming in. My goal is to have that set up either next week or the week after, to where when it comes to attendance, you all can just scan the card. The problem is I don't have access to that database yet, so I have to have that set up. So for now, I'm still going to have you all just sign in. When you all leave, there'll be attendance sheets, much like there were last week. Just put your initials next to your name, and you all can head out. So sound good on that? All right. So let me introduce our main speaker real quick. Our main speaker is Alan Bragg. He's the customer services manager with Appalachian Power. And I'm sure when some of you are thinking Appalachian Power, you think, oh, this is for the electricals in the room. But you might be surprised how many different opportunities that AEP has for civils and mechanicals in the room. And I know that they'll probably be looking to accrue some young engineers in the not too distant future. So this is definitely someone you'll want to pay attention to. So with that, let me turn it over to Mr. Bragg. So let's give him a round of applause.
Bigger crowd than there was the last time I was here. So I appreciate you, Dr. Michelson, for giving me the opportunity to come speak, and I hope I won't let you down. I want to talk about opportunities for engineering graduates within electrical utilities. And a couple of things I got to admit. When Dr. Salem mentioned the word thermodynamics, it kind of sent a chill up my spine. I'm an electrical engineer by trade. We called that thermo for non-believers. We had to have one class to get through. Again, I'm an electrical engineer. I graduated from West Virginia Tech, just up the river, just up the Kanawha River. Recently moved to Beckley, and I got my master's degree in engineering management from Marshall. So I have a connection here. First, a little bit about our company. Our parent is American Electric Power. We serve portions of 10 states, from Texas up through West Virginia, from Michigan down through Virginia, Oklahoma, Arkansas, etc. 2 of those states are non-regulated, meaning that customers can choose their supplier of the generation services. The wires company is owned by us. You can't really choose that. In the other 9 states, we own all the generation, all the transmission, and all the distribution, and we'll talk about those a little bit more. We serve 5.2 million customers with 18,000 employees. We own every known type of power plant known to man. Around here, there's a lot of coal-fired plants because this is where the coal is. We own natural gas, hydro. We own wind contracts. We have solar. We actually own in Texas the largest solar plant in the country. And nuclear. We have 1 nuclear plant in Michigan. Our transmission grid, the high voltage electrical transmission from anywhere from 46,000 volts up to 765,000 volts. We own the largest grid in the U.S. And I work for the subsidiary named Appalachian Power. We serve portions of West Virginia, Virginia, and Tennessee. About 1 million customers. So, as Dr. Michelson said, you normally think of an electric utility as hiring electrical engineers, which we do. We hire a lot of them, actually, and we use them in nearly every aspect of our business. But we also hire mechanical, civil, chemicals, environmental, industrial, nuclear. I understand you guys now have a computer engineering. We hire a lot of computer engineers as well. I didn't leave them on the list because I didn't have them on the list because I didn't know you had the program. But really what we are is a big engineering firm. Everything we do revolves around technology and engineering, so we hire a ton of engineers every year. I will tell you up front, we're thrilled that Marshall now has the engineering programs that it has. Over the last couple of years, we've had trouble finding and recruiting engineering graduates. There's lots of opportunity out there right now. In fact, the last opening we had was for a distribution engineer and an electrical engineer in our Milton, West Virginia office. We had 1 degreed engineer apply for the position, and they're really nice high-dollar positions. So keep that in mind when you're looking for a role. And I got to tell you too, most of our engineers are my age. So there's going to be an awful lot of opportunities within the next 5 to 10 years for new engineering graduates to stroll into some really nice jobs. And I don't know how many of you are local from the local area, but this is the type of a job that gives you an opportunity to stay close to home if that's what you want. Or it gives you an opportunity to move. Again, we serve as far south as Corpus Christi, Texas. If you're looking for the sun, we offer that kind of opportunity for you too. So it's not just a local position, but if that's what you want, we can offer that to you. Okay, so we all start out at the power plants, right? You got to make the energy, the electrical energy, before you can transmit it on the wires. So who do we hire and what do we do in power plants? Lots of mechanical engineers. I think you raised your hand as a mechanical engineer. Hire lots of mechanical engineers. Do a lot around the thermal cycle, especially with coal plants and natural gas plants. You use a fuel to turn water into steam, and you use the steam to drive the turbine, which spins the generator, right? So there's a lot of work around the thermal steam cycle. We have to have these plants be as efficient as they possibly can be. You want to wring every available kilowatt hour out of every BTU of coal that you burn, because that's a huge expense. And so you want your processes and your systems to be efficient. Electrical engineering within the plants. I started out at Big Sandy Power Plant, which is just across the river in Louisa, Kentucky. An electrical engineer in a power plant will do lots of work around controls, controlling motors and processes and systems, protection and control. We'll talk some more about that a little bit later, because it really is very important on the transmission side. Chemical engineering, water quality, air quality, fuel testing. Again, you're buying a very valuable product when you buy a fuel, whether it's gas or coal or whatever. You got to make sure that you're buying what you think you're buying. You don't want more ash or less BTUs or whatever than what you think you're buying. So you trust your suppliers, but you verify what they're telling you too. So chemical engineers do a lot of that. We're going to talk a lot about environmental near the end of the presentation. Lots of air and water quality, compliance with federal, state, and local rules. Civil engineering, mostly on the construction side of a plant. These are huge. These facilities are 10 and 12-story tall buildings with huge boilers hanging from the steel. You got to have good civil engineers to do your design for that. Nuclear engineering, we don't do a lot of that around here, but we hire them. And maybe the most important thing overall, I know you all think you want to be engineers for the rest of your life, but there's lots of opportunities in project management and leadership roles within the company. So there's opportunities to stay in those roles if you want to. The higher levels of the pay grades and higher levels of engineering roles top out at a very, very high pay scale. And I wanted to share this with you. When I was a young engineer, nobody really worried all that much about having a professional engineering license. Nobody in management within the company really cared about that. That's become more and more important over time. And so I would encourage you, as soon as you graduate, start taking your FE and get your PE as soon as you possibly can, because the highest, within our company and probably most, but the highest pay grades, the highest level of engineering titles that you can achieve, they require a PE. So while you may never use it, you may never stamp a drawing, if you want to get to if you don't want to be precluded from getting to the highest levels within your profession, don't wait to get your PE, because as you get older, you're going to lose brain cells and you're going to forget how to do the math, right? So I would encourage you up front to do that. So transmission, the folks who build, work on, operate these type of structures, you see them all over the place. We own them, maintain them, build them all the time. Civil engineering is a really big part of that. Each and every one of these, they all look alike, but each and every one of those structures is engineered, period, by itself. You got the terrain issues that you can see here. The span lengths on either side of those structures are, it may be 200 feet, it may be 4,000 feet. So every one of these structures are engineered to itself. So lots of civil engineering goes into that. Electrical engineering, load studies. We want to make sure we're not burning down transmission lines because we have too much customer load on it. Planning of systems, equipment sizing, breakers, transmission or transformers, etc. We size all those things. Environmental engineering. It's a huge part of transmission line construction. We have to do BAT studies on every line that we build, every structure that we build. We can only construct these during the winter time when the bats aren't there, right? So we pay environmental engineers to go out and trap bats and all those kind of things. Lots of water quality studies, compliance studies. I mean, every law under the sun we will comply with, and we have to have environmental engineers to make sure that they're keeping us on track. So lots of opportunities, and I will say this: within the last 5 years, we've built more transmission lines than I've seen in my entire career. These facilities are built to last 100 years, and we have some of those facilities that are still in service after 100 years. And so we're in the process of rebuilding them. We finished a year or so ago with a 52-mile line between the John Amos Power Plant, which is in St. Albans, West Virginia, up to Cabin Creek, which is the first toll booth on the West Virginia Turnpike. We just finished rebuilding that. We changed out wire that's the size of your thumb, and put in wire that's the size of your wrist, right? Because we shut down a couple power plants, and you got to have the load carrying capability to serve your customers. Every structure had to be changed. Everyone had to be engineered. Yes, sir.
Do most of your civil engineers work directly through you, or do you contract out?
Both. We have a number of them that are actual employees of the company, but we do hire lots of contracted civil engineering services. We use 2 or 3 different companies to do that for us because, frankly, the work comes and goes. So you want to have your steady state employees to cover everything, and then you subsidize your workforce with contractors to take care of the peaks. Substations. The substation that serves this facility and most of Huntington is just on the back side of the engineering building. It's called East Huntington. We're getting ready to do a major project there within the next couple of years. It's a major field within the company. Lots of civil engineering. Every one of these structures has to be engineered and designed. The foundations are hugely important. So we do a lot of that. Electrical, I want to talk a little bit about protection and control. If you don't know what that is, how many of you are electrical? Okay, good. So protection and control, that's trying to protect, it's the fuses and breakers that will protect the major pieces of equipment. If there's a fault out on this line, we want that breaker to operate before it damages that transformer, right? Because that transformer is millions of dollars, and you do not want to see it burn down because that breaker didn't trip. So you got to make sure that you've got enough fault current at the end of the piece of facility, at the end of the facility you're watching, to make sure that it'll trip that breaker, right? You've got to make sure that the timing is proper, and that your zones of protection are proper to where you don't trip everything. So I mean, if I've got a fault on this piece of line here, I want it just tripping that piece of line. I don't want all the customers served from the rest to be affected also. We also have a duty to protect the public. I don't want one of these lines laying on the ground energized. I want the breaker to trip so that it's not energized and it doesn't electrocute people if they walk up on it. So it's really important, and this is the time that those folks are my age too, right? So we've got to get really good, really sharp people in those roles because it's so important. Again, environmental, lots of construction on these. The foundations are huge under these structures. You don't want runoff. You don't want anything like that to affect you. Distribution, just so you know, and I should have said this earlier, I started out at a power plant, and I went to work in the distribution organization after that, and most recently I've been in a customer services role. The folks who report to me are the engineers who work with our largest industrial customers. So one of my employees handles the account from Steele, West Virginia, and for Marshall, okay? So I'm one of the few people within the company who have been around all those different organizations. Usually you get typecast. If you start out at a power plant, generally you're going to be at a power plant. But I would encourage you, if you do start with any kind of a company, stick your toe in the water in the other different organizations within the company, because you never know. I mean, you might like other places better. And I will tell you, a variety of background and a diverse background is going to give you opportunities in the future if you want to go into leadership. They like people. Companies like people, not just ours. Companies like people with a diverse background that they feel they understand everything that's going on with the company. So kind of a little bit out of order, but it's important for your future. Mostly on the distribution side, it's mostly electrical engineers on the distribution side. Engineers don't actually climb the poles, but it was a cool picture, so I figured I'd put it in there. A lot of equipment sizing. Make sure you got the right size transformer, the right size wire. Load flow studies. You want to make sure that you can carry all the load that you need to carry. Project management, operations, leadership on those. So that ends the part of the presentation where we were talking about opportunities within the company, but I want to talk a little bit about a couple of topics that might be of interest to you. The first is environmental. As I said earlier, we are a fossil fuel-based utility. That's what happens when you live in the middle of the coal fields and the gas fields. We have an obligation to our customers to try and find the cheapest form of generation that we possibly can. When you live here, that's coal. And I'll tell you that, and it has historically been, at this point in time, it's still a little cheaper to burn coal to make electricity or to burn gas to make electricity than it is to use solar or wind. And even though we have all those other sources, solar and wind are coming close. The cost per kilowatt hour to be generated with wind and solar is getting very, very close to the cost of fossil fuels. Yes?
Is that just based off of the efficiency?
It is. It is. With solar, and I'll tell you this is a God's honest truth. When I started with this company, it took more kilowatt hours, more electrical energy to build a solar panel than it would ever produce in its lifetime. Okay? That's not true anymore. It's not true anymore. So what we've done recently is we've put out bids for we call them RFPs, requests for proposals, for solar and wind, because politically you have to do that, right? From a financial perspective, you want to do that if they're close in cost or lower. And what we found is the bids we're getting back on solar and wind are tremendously cheaper than they were even 2 years ago and 5 years ago. So my gut feeling tells me that we're coming into a point where you're going to see much, much more solar and wind. The problem here is there's not enough sun and there's not enough wind to make it efficient. So the wind facilities that we contract for are in the mountains in the eastern part of West Virginia, around Elkins and Greenbrier County over there. Higher elevation, more wind. And also in that Indiana-Ohio corridor, even though we serve portions of West Virginia, Virginia, and Tennessee, we've contracted for wind resources in that Ohio-Indiana corridor, because that's where the wind is. Solar, we still don't get as many days of sunshine here as they do in Southern California or the Southeast. So not quite there, but we've got a couple of big developers who are looking to do that. So let me say this about the environment. So we have, if you've been east on I-64, we're the folks who own the John Amos power plant right there at the St. Albans exit. And you see these stacks, those are 1,000 feet tall, and they're right beside the interstate. And so, as you can imagine, we get lots of attention, okay? Not that we wouldn't anyhow, but it's especially important. We will comply with every environmental law that's on the books, okay? And we've installed, when these plants were built in the early 70s, they were just boilers to a tall stack, right? And the theory was if you put the smoke high enough in the air that it'll dissipate by the time it gets to the ground, right? So what we've done since then is we've installed electrostatic precipitators, which are devices that act like a vacuum cleaner that will capture the ash and other particulate matter before it goes out the stack. More recently, we've installed selective catalytic reactors, SCRs, and scrubbers, flue gas desulfurization units. And what those devices do is they take out the sulfur oxides, the nitrogen oxides, and the mercury from the waste stream. We spent $1.2 billion with a B to retrofit the Amos plant with SCRs and scrubbers, but now we remove 90 to 95% of all those things from the waste stream. So what you'll see if you drive up I-64 is, of course, you'll see water vapor coming out of the cooling towers because that's all that ever was. But now you'll see a white puffy cloud coming out of the big tall stacks, and mostly what that is water vapor. So we spent $1.2 billion to retrofit a power plant that cost less than $1 billion to start with. So we've more than doubled the investment at that plant to comply with environmental regulations, and we are in compliance with every environmental regulation at the federal and state level, and this company will always be in compliance with those. So back on the renewables side, we haven't talked about hydroelectric facilities. If you've ever been to Smith Mountain Lake in Virginia, that's one of our hydroelectric facilities. We built the dam, we own the lake, and it's a pump storage facility. So you take the water out of the main pool where the lake is, everybody's water skiing. You take the water out of that, you run it through the water turbines, and you make electricity with it. It's a pump storage facility, which means there's a lower pool. It's called Leesville Lake. And at night, when the load's down, we pump the water back up into the main reservoir, and we let it off again the next day to produce electricity. There is a huge peak. Most of you, I'm sure, know what a sine wave is. Our load profile looks just like a sine wave. It's higher in the afternoon in the summer, and it's not very high. You know, it's in the summertime, it's up here, and in the evening, at night, it's down here. So off-peak electricity is really cheap, so it makes sense to use those same kilowatt hours and pump that water back up and run them through and sell them when it's during a peak or a high value time. We also have hydroelectric facilities in every Corps of Engineer dam along the river, along the Ohio and Kanawha River. If you've ever been boating or around the Kanawha River or the Ohio, there's flood control dams. There's locks that raise and lower the level of boats so that they can travel. We have run-of-the-river hydro plants in every one of those dams. So we take advantage of the difference in head pressure between the upper level and the lower level. We talked about wind already. One other thing about renewables, wind and solar, they only produce when the wind's blowing and the sun's shining, okay? So we believe that you've got to have all forms of generation. We embrace those. But there's always going to be a need for baseload plants, the gas, the coal, the nuclear, and the hydro, because the wind doesn't always blow and the sun doesn't always shine. So contrary to what you hear, we'll never go to all renewables. We will get more. There will be more over time, but there will always be baseload as well. And the last thing that I want to talk about formally is energy efficiency. The cheapest form of generation is the form that you don't have to build. It's the form that you don't have to purchase fuel for. And one of the most cost-effective forms of generation is energy efficiency programs. And we have some really good energy efficiency programs in West Virginia. Lots of folks take care of our or take advantage of our lighting programs. We offer rebates for, like these lights here. We probably provided a rebate to the college, to the university, to install LED lighting.
So would they be purchased through your company?
No. What we do, we've got a couple of different programs. If you go to Lowe's or Home Depot or any of the big box retail stores, we pay them to discount the price of the bulbs. So if you go and you buy one of these types of bulbs, it'll be subsidized by us, okay? And then, so what we end up doing is, and I just did this, my wife owns a little store, and so I changed out all her lights to LED. I saved 75% of the energy. Like I went from nearly 4 kW worth of lights down to less than 1. So I cut it by 3/4, and the company provided me a rebate that's about 20% of the total installed cost. So when you take out those lights and you replace them with something else, you apply for a rebate with the company, and they just send you a check. We just send a check. So we've got programs for commercial industrial customers around process. Variable frequency drives are big energy savers, and lots of customized programs. Very popular with our customers, as you can imagine. Everybody likes to get a check for something you want to do anyhow. So we're really proud of those, and I think we'll continue. The folks within the state really like those programs. We are going to, within the next couple of years, we're going to install AMI metering, smart meters, and as a part of that, those talk really well with thermostats, and there's I talked earlier about peak load periods being very expensive and off-peak not being very expensive. There's an opportunity for our meter to talk to your thermostat to say, hey, you might want to cut back because it's expensive right now. And so we don't have it yet, but we're going to. There's all kinds of opportunities around energy efficiency, and frankly, we do a lot of customized programs. People think about ways to make their processes more efficient, and we'll pay you to do it. So, and that seems a little crazy to pay you for not using my product, but that's what we do. Yes?
How are you all incentivized to subsidize the purchase of these bulbs? Because, I mean, in the end, the customer's going to be paying you less
Right.
for your energy.
Right.
Which, I'm not saying you guys are out to only make money and hurt people,
Right.
but, I mean, is the government this?
No, it comes back through rates. There is a fund that's paid for by ratepayers that it's 50 50 cents per 1,000 kilowatt hours. And the folks who take advantage of the programs are the ones that reap rewards, but it's small enough that it doesn't really affect other people. So yeah, that's where it comes from. And we created these programs because, number one, we thought it was the right thing to do, but a lot of our stakeholders, our customers and industrial groups and others wanted us to do it as well. So, I sit in on those conversations, and there was a lot of tugging back and forth, but eventually we got to some really nice programs. So, I don't think I've missed anything, but if I had, maybe you can ask a question. That's the end of my formal program. Yes?
You guys do much stuff with hydraulic fracturing?
We don't, but we do have some gas-fired plants. Appalachian Power Company owns a combined cycle gas plant, and we own a simple cycle gas plant too. And the difference between those two is the simple cycle is like a jet engine. You just burn gas and it turns the turbine. And the combined cycle is that, plus it has heat recovery on the back end. So the heat that comes out of the back end of the turbine heats up water, creates steam, runs a steam turbine. So we buy the gas. We don't frack for it ourselves. We don't mine coal. We buy coal. So we figured out we're lots better at making and delivering electricity than we ever were at mining coal. So we got out of that business. I saw another hand in the back. Any other questions? Thank you for your attention.
First off, let's give him a round of applause.
Thank you.
Before everybody packs up and leaves, I have 2 points that I want to make. First off, Mr. Bragg mentioned this thing called the FE exam, and he mentioned the process for receiving your license. I believe it's on October 19th, but I'm actually going to have representatives from the licensing board coming to this class talking to you about the licensing process. So I would mention that. The second point worth mentioning, and this is really important to everybody in here, so I'd make sure that you pay attention. When somebody like Mr. Bragg or a consulting firm or a DOH or what have you emails me and says, Dr. Mike, we've got some positions and we need to hire some engineers. What I do is I take that job posting or that opportunity, I send it to Lee McDonald, who's our administrative assistant in engineering. And what she does is she emails every student in the program. Now, I know your Marshall email address you can get a lot of stuff in there, but I would highly recommend that you pay attention to her emails, because usually it's really important stuff like registration dates, making sure that you're getting paperwork done, and job opportunities. The folks that pay attention to those emails are the folks who are getting internships and co-ops and jobs when they get out of here. So make sure that you're paying attention to that. One last thing. The attendance sheets are going to be in the back of the room. Make sure you sign that on your way out. Don't forget your quiz due next Friday at 11. Y'all have a great weekend.